First light images are typically just showcasing the instrument. Of course, to show the public, it's nice to have it focused. So we went through the focusing procedure. That takes about a week. And towards the end, we got a very fine, crisp, deep image. And so what we're going to show for the first light image is just one of these exposures. In case of the VIS instrument, it's going to be a 566-second integration image. The physical size of the VIS focal plane is about 0.7 degrees, 0.7 degrees. One of the primary science goals for Euclid is weak lensing survey. And weak lensing relies on the distortion of the galaxy images. And so what we want is a very clean, crisp image of galaxies so that we have a reliable source of what this weak lensing distortion could look like. For the first light, we were going to show a detail of the full focal plane. And this is for one CCD in particular, which happens to contain a stellar cluster, a large galaxy, another large galaxy, and a very bright star. Nothing has been processed. The cosmic rays are still there. The bias has not been removed.
Now, besides this beautiful VIS image you see here, we also observe in the infrared. And for that we have an infrared instrument. It's called NISP, near infrared spectrometer and photometer.
We turn on the NISP instrument very quickly after the launch of the Euclid satellite. Mostly we turn on the instrument control unit to monitor the cooldown of the instrument. And once the temperature reaches threshold, so below 130 Kelvin, we turn on the data processing unit and the focal plane array of the NISP instrument. We undergo first several tests on the NISP instrument to verify operational behavior of the NISP instrument. The image you show is a raw image, so no processing. I just add a little color to emphasize position of star. Otherwise, the image is not naturally black and white because our detector are monochromatic detector. And you can see in this image some cosmic ray event in the foreground from the cosmic sky in the background here. So the image quality is evaluated by measure the size of the star because the stars are very far away, they are like point source. What we measure from star on the instrument is what we call the point spread function. So the response of the instrument to a point-like source. And the smallest this response, the higher the quality of the image. So basically we measure the size of the star here to control the quality of the image.
The infrared part, we can determine from the spectral energy distribution of these galaxies, the redshift. We call it photometric redshift. So together, combined with the infrared observations and the optical observation, we do the weak lensing experiment.
So here we have a first light image from NISP, but this is the spectroscopy. And what this means is that what you're seeing here is that each of these lines is a spectrum of the sources that NISP generally detects. So if you saw the NISP image, you had all of the little points, some of them stars, a lot of them galaxies, and each of those points is now smeared out into its wavelength components to get a spectrum. And what we can do with the spectroscopy for galaxies is we can measure the distances. And this is very important for galaxy clustering, which is one of the main goals of Euclid. And this tells you how far each of the galaxies is, and with that information you can then build a 3D map of what the galaxies look like around us.
What you see here now is what we call first light. So we are very proud to show that we can really see what we expected. If you look at the images very carefully, you still see defects, that is cosmic rays and all these things. In the first few months of Euclid, we are going to check out the instruments, but also do the calibrations, necessary calibrations. And it's not yet looking at the sky which we want to do after we have done all these verifications. Once we look at the sky, we come with some images we will take during this checkout phase, which is taken in a way we will do during the survey. And that will tell us how good the quality is of the survey. We have already selected a set of images, and they must be really stunning. If this is already so nice, I mean, the images we will show you will be extremely stunning, I think.